1.1 graphs. This is kind of a review of stuff that you've seen already. Now, graphs, though, are made up of horizontal and vertical number lines. Horizontal, of course, left and right. Vertical, straight up and down. What we end up doing with these, see if I can do this with some technology decently, is we're gonna start combining these like this. Okay, so it's gonna make kind of a cross. Of course, there'll be more lines. It'll look like city streets, at least in some cities, like this one. Okay, so we've taken the horizontal number line and the vertical one, and we've combined the two together. Now, there's some vocabulary that you have to be familiar with so that when I refer to it, that you're not like, what the crap are you talking about, right? So first up, we have the x-axis, which is the horizontal number line right here. All right, now we have the y-axis, which is the vertical number line right here. What you'll have to remember on this is that right at the middle, see if I can do this with a decent color there, right in the middle of the x-axis right here, and it'll be right on the y-axis, that's the value 0 on the x-axis, and then the y-axis, its 0 value is right here where the x-axis meets it, okay? And then if you go to the right on the x-axis, those are positives, left is negative. For the y-axis, downwards is negative and upwards is positive. From time to time on a graph, you may see right in the middle, they'll have some students say that's a 0. It is not a 0. It is the letter O, O for origin. So right there at the middle, I'll put the point there, right there. That's the origin. Now, the nice thing about the coordinate grid, coordinate plane, I guess, whatever, is that it is like city streets, and each corner is its own location, right? So if I were to look at this street corner, we can identify that location through this grid with an ordered pair. Now you see down here, it says the ordered pairs, we have X value first and then the Y value second. That's always alphabetical. So the X value would be first. So I would be looking on this, I'm going to call it a street right now, but this line, and I can see that it would be on this. Again, I'm going to say it's a street. It's on this street for the x-axis. That is 1, 2, 3, 4, 5, 6, 7, 8. So the x value here is positive 8. And then the y value, the corresponding y value, again, I just follow this street over until I get to the y-axis. And I can see that that value would be 1, 2, 3, 4, 5, 6, 7. Well, it's 8 as well. I didn't mean for that to happen, but it did. So the x value is 8, the y value is 8. We'll see some more. But again, when we see an ordered pair like this, it's crucial that you understand what it is because we're going to see a ton in this class. So let's identify the quadrants on these. We have the x-axis, y-axis, the origin, and the ordered pairs. Quadrants, okay, because it's being split up into 4 parts by the 2 axes. And this may seem weird, but quadrant 1's in the top right. Why is it in the top right? I don't know. But I assume that there was some math nerd at some point in time that was like, watch this, quadrant 1 in the top right. And then every other math nerd was like, yeah, we got him, right? Not only that, but usually we'd look at this and think it's going to go clockwise. It's counterclockwise, which means quadrant 2 is the top left, quadrant 3 is the bottom left, and then quadrant 4 is in the bottom right. And you'll notice as well that I put those in Roman numerals. Why are they in Roman numerals? I don't know if the Romans really just like quadrants, or if there was a math nerd in Rome that was like, I'm going to watch this, I'm going to put it in the top right. I have no idea. But if you don't use, this is going to seem weird too. If you don't use Roman numerals and you show this to a math nerd, and by math nerd I'm talking about professors and teachers, they may freak out. Okay, now I've just given you a brilliant key on how to really annoy the crap out of math people. I like to as well. The reason why is because I'm not disturbed by those kinds of things, but a lot of math nerds are. So right here, we're going to find the ordered pair for each of these points. Now this goes back really to 920 type stuff, but it's a great review. All right, so I'm going to start in the top right. I don't know, it's just out there. So if I were to look at the ordered pair for this point right here, this ordered pair, I can see I can follow this line down. and I can see the x value is 4. It's not even showing the x for the x-axis, but there should be one there. Same for the y-axis, but it doesn't have to. And then again, I want to know the y value as well, so I just follow this line over. I can see it's a y value of 3. The ordered pair is 4, 3. Now, for ordered pairs, it is crucial that you use parentheses and a comma between. Hopefully that makes sense, right? This is now the number 43, but with the comma, now it's 4, 3, all right? If you don't use parentheses, then mathematically you're using the wrong language, which in real life is okay, right? Like, I don't think you go home and talk to your friends mathematically. But in a math class, we need you to speak math language, okay? All right, so I'm going to work. Let's go to this point right here. So this one, again, we're just looking. Let's start with the x value. I go down here. It's right in the middle. That's the origin. But the x value itself is 0. And the y value is right on the y value. It's telling us the y value is 2. I guess I'm going counterclockwise. It doesn't matter. So for this green point, once again, I follow down. I see the x value is -2, and the y value corresponds with a 2 value. That comma didn't work very well. It's okay. And then this point right here, it's right on the x value of -3, which means the y value is 0. When we can follow this line over to see on the y-axis, that is a 0 value. And then this last one here, same idea. I want the x value first, and I can see that's -1, and following over to the y value of -4. All right, now, so the last slide there, we were actually identifying the ordered pairs of points that they gave us. Now they're giving us ordered pairs. Again, that's a location on the graph represented by these values. I don't know why there's so many, but there is. Let's go to -4, 6, right? So again, it's always going to be x value and then the y value. So let's find -4, 6. I'll do in blue. So on the y-axis, starting from the x-axis, starting at 0, I'd go to the left 4, 1, 2, 3, 4, and then I would have to go up 6. So 1, 2, 3, 4, 5, 6. Boom, there it is. I will label it -4, 6. And I'll also get rid of the line because then it looks pretty. But I'm starting from the origin on these. Some of you guys are like, Sal, that's kind of a waste of time for me. Then okay, I'm going back to the basics on this stuff. And then we got 0, -3, so that's an x value 0. That's down 3. 1, 2, 3. Boom, there it is. 0, -3. Now you'll notice this point that we just put on there is a point that's directly on the y-axis. That is what we call a y-intercept, which we'll identify because it's saying determine which quadrant and stuff. But let's put these on the graph first. So -1, -4. So again, that's left 1 and then down 4. That's this point. It's pretty close. -1, -4. And then 1, -6. Oh, crap. 1, -6. Sorry, it's getting really cluttered there. Not on purpose, though. And then 7, 0, that's an x value of 7, and then a y value 0. That's going to be right on the x-axis, which, when it asks, I guess I spilled the beans on the one that's on the x-axis. My bad. Let's see, the next one, 0, 0, that's right at the origin. The origin is always at 0, 0. And then 9, 8, we'll do, I guess, do in red. So 9 x value, that's 9 to the right, then 8 up, boom. I think I got that. It's kind of small on my iPad. I think I got them all on the graph. But now we need to identify the location of each. So now we're ready to identify the locations of these. So -4, 6, that's the blue point in the top left. That would be quadrant 2. I'm going to put a Q with that. The math nerd in me really wants to write the word quadrant, but I'm not going to. I'm going to resist it. 0, -3, we can see that one. It's the red point there, and it's directly on the y-axis. We addressed that as well. So that's directly on the y-axis. You'll have to do this on the assignment, by the way. -1, -4, it's really close to the y-axis. It's just not directly on it, which means it is in a quadrant. And that would be quadrant 3, so Q3. You're welcome to write the word quadrant, by the way, but I'm not going to. 1, -6. This is screen point, which got a little cluttered there. That would be quadrant 4. I think we get one in each of the quadrants, right? And then 7, 7, 0, that's the orange point there. That's directly on the x-axis. And then 0, 0 is always the origin. And it would be good to get used to seeing that if you see 0, 0, you just know it's the origin, which is why I didn't point it out on the graph. But you can see on the graph it's right where the two axes meet. And then finally 9, 8, it's the only point I can see in quadrant 1. Okay, so just a quick review here. Quadrant 1, maybe I should have done this before we did it, but quadrant 1, 2, 3, and 4. Well, now onwards to the calculation stuff. What is a solution? Now this may seem like a weird question, but a solution is when you can take the letters, which we call variables in an equation, and replace them with numbers, but it has to make the equation true. So one thing that we struggle with is this sign right here, equals. The equal sign. Okay, because the equal sign it's a conditional statement, meaning it could be true, which is what we want. It could be false. For example, I could make the statement 1 = 2, and that's okay. It's just false. Is it okay for it to be false? It is. It's just we now know that it's false, okay? There are curriculums coming which will eventually say that's okay, but it's not okay. It's just false. So I can change this, though. I can say, well, what if I do 1 + 1 = 2? Now it's true. Now it is a true statement, right? Now, if we go back to equations with one variable, then if I were to say, look, let's say that it's x + 1, then we would need a value to replace that x with to make this true, okay? And what we just saw, if you were to replace the x with 1, that would make a true statement, 1 + 1 = 2. Now to take this a step further, what we're going to see, just like we saw on the grid, is we should expect to see two variables, x and y. Now the question is, and this isn't really meant to be a trick question, but can we think of a value that would make this true? And one that comes to my mind is 0, 2. Replace the x with 0, replace the y with 2, true statement right there. Which means that on the graph, this point can go directly on the graph. Okay, well, what about 1, 1? Would that work? And the answer is yes. That would also make the equation true. Now, as much as you want me to, I'm not going to list all of the ordered pairs that would make this true, because there's an infinite number. Okay, so because there's an infinite number, it's nice to be able to use a graph to show that, because the graph will tell you any point on the graph should make the original equation true, even the fractional ones. Oh, so what we're going to see on the assignment as well is they may give us one value. They may say, hey, look at that equation right there. Well, what if x is 5? And then they're going to say, you solve for y, which, by the way, would be -3. I said that, and then I realized you probably don't care. But that would work, okay? So there are ways to do that. If we need, we may have to use some principles of equality. So let's go over principles of equality. This goes back to solving equations like 3x + 5 = 8. I just made that up. But principles of equality are used. You can see here, this is all abstract. This is very nerdy speak right here. So it's just saying if you have something, I'm going to go with the nerd stuff. If you have something that's equal to something else, you can add the same thing to both sides. You're still good, okay? Or you can subtract the same thing, or multiply the same thing, or divide the same thing. It's possible you've heard this, and this is principles of equality. Whatever you do to one side of the equation, you just have to do to the other side in order to maintain equality. If you don't, then you've changed the problem, and then what the crap. But we do these with purpose. For example, addition and subtraction. I've done better brackets, but that'll do. Addition or subtraction. We use addition or subtraction in order to force there to be zeros. Well, we may see some examples for that, okay? But if I see a value that I don't want in an equation, I can zero it out with either addition or subtraction principles of equality. If I wanted to, I can also use multiplication or division. It's just if I use these two, then it means that I'm trying to make ones. Now, again, this is with purpose, right? So if I'm making a 1, it's really to make the coefficient a 1. Sal, what the crap is a coefficient? It's a number that's being multiplied by a letter. So let's go back to that theoretical equation, 3x plus 2 equals 8. I don't even know if that's the same one. But if I saw 3x, the coefficient of x is 3. In fact, let's make this a little bit more applicable, right? If I said 3x plus 2y equals 8, I now have two coefficients. I have a 3 coefficient and then a 2 coefficient. It just has to be a number that's being multiplied by a letter. That is it. Now it is a coefficient. But when we solve equations, generally speaking, we want it to be a 1, which we can force to happen with either multiplication or division. So here's some good news for you if you're going into some kind of math-related field, is if you can just understand that sometimes we can force the math to do what we want it to do, then there's no math you cannot do, okay? And sometimes it's making stuff be 0. Sometimes it's making it be a 1. Sometimes it's making them be common denominators. You see what I'm saying? You force that to happen. The problem is that a lot of students let the math take control of them, and it will ruin your life, just like it has many lives before. So we don't want that to happen, so we got our principles of equality. That's one tool we can use. And if we use it right, we can take advantage, and, well, not advantage. We can take control of the math and use it the way that we want to use it, okay? So complete the ordered pair so that it is a solution for the given linear equation. Fair enough. What I have right here is an x value, right? Because it's x, y. And so in the equation that's given, 2x plus 2y, which should equal 8, it's saying the x value is, well, it should be -2, right? So if I replace that x with -2, all I need to do is find the corresponding y value that still makes it a true statement, right? So right off the bat, I see I do have some distribution. Some people would say that's not distribution. Distribution is multiplication. So 2 times -2 would be -4. And then I can just kind of drop everything else. But now what I have is a new equation that I need to solve. To do this next part, I'm gonna use the principle of equality. Now you've noticed right here that I've drawn the line through the equal sign. That's because I know with principles of equality, if I do something to one side of that line, I have to show it on the other side. But what I would like right now from my principles of equality is to just be able to drop the 2y so that it's all by itself. I don't want that -4 with it. So how do I get rid of -4? Well, by get rid of, I mean make it a 0, just like we saw on that last slide. How do you make it -4 0? Just add 4. But once again, that's a principle of equality. So if you do it to one side, you just make sure you do it to the other side, okay? Well, what happens here? Well, -4 plus 4 is 0. That would be a positive 2y, which we've dropped. And then 8 plus 4 is 12. Well, here's the thing is math. In math, when we see a 0 like we see there, we get to ignore it, okay? So by ignore it, I mean we get to pretend like it never even existed, just like we would with people that are zeros, okay? Sorry, should I not have said that? Should I not have said that? My bad. In any case, so you guys are good. We're good. So I actually just show the 0 like this. Some students say I've circled those two. No, it's a 0, okay? But remember, in the end, what we really need is just y equals something, and then we get to replace it there. So 2y's is no good for us. So I'm going to force this, again, with the principle of equality to be a 1y. Well, how do you force a 2 to become a 1? Well, like we saw on the last slide, we can force any value to become a 1 with either multiplication or division principles of equality. I know that you can make any number become a 1 by dividing it by itself. So 2 divided by 2 is 1. And yes, that's kind of a funky one that I just put on there. But it's a slanted one. That's okay. And then we'd have to do it on the other side. So 12 divided by 2 is 6. I can even check. So I can go back to the original. I can say 2 times -2 is -4. 2 times 6 is 12. -4 plus 12 is actually 8. That checks off. And now I know that if I replace the y with 6 and the x with -2 in that equation, I now have a solution to that equation. And even to take that further, if I were to graph it, hopefully you don't have to graph stuff by hand, but if I were to graph it, I would put it at -2 and 1, 2, 3, 4, 5, 6. It would give me this point right there. -2, 6. Yeah, sorry, my lines are kind of jacked up. I did my best. Okay, but now that I have that point, I'm ready to graph the next point. Hopefully you are too. So let's go back to the original equation, and I'm running out of space here, but here we go. 2x plus 2y equals 8. Now again, I'm going to rush through this one just because we've seen it already. This is a y value that is given to us, -1, so I'm going to replace that y with -1. And I'm going to solve for the corresponding x value. So 2 times -1 is -2. You'll see that I've replaced that plus sign with now a -2 or -2 sign, and this is going to equal 8. So principles of equality now to solve. I'm going to add 2 to both sides. To zero that out, drop my 2x, which equals 10. And then the last thing I want here is a 1x. So I'm going to divide both sides by 2. And 10 divided by 2 is 5, which makes this ordered pair 5, -1. So that would be 1, that's x value 5. 1, 2, 3, 4, 5, and then y value -1. That's this point. Now the beauty about lines that like this, it says linear. That tells us it's a straight line. So what I can do, because I'm a math nerd, because I don't think you guys would want to, but I'm going to do this. I want a different color though. Green, there we go. Oh crap. I can get those two. There we go. What you can do now is connect those 2 points together with a line, and every ordered pair, we're pretending like I did this, I drew it very well. But every point on that line would make the original equation true, every single ordered pair, including the fractional ones. In fact, you notice I put arrows on the end. That means it extends forever. So you could get into some extraordinarily large numbers, but you can also get some extraordinarily small numbers as well. This one, determine whether these ordered pairs are solutions for this equation. No problem. So once again, we'll start with this one. We got x value of -1, y value -0.5. So, oh good, I got my trusty calculator. Our equation is -2x plus 2y equals 1. Now, like I said, I'm going to do this calculation, but the calculator is going to do the heavy lifting for me right here. So I'm not going to do it order of operations as much as you want me to. Why? Because the calculator knows the order of operations. How freaking awesome, right? So I'm going to take the x, and I'm going to replace it with -1. Tried to make them red. And then the y value, I'm going to replace with that decimal, -0.5. Try to give yourself more space. Now it's asking, is it the solution, right? So I'm going to put a question mark over the equal sign. If it becomes true, then it is the solution. So I'm going to type this in. -2 times -1 plus 2 times -0.5. Now, if I push enter and I see that it does actually equal 1, then I know that it is a solution and it would be true because it would be a true statement. If it gives me anything else, it is not a solution. I push enter, and all this garbage right here is actually 1, and 1 does equal 1. Hopefully we know that's true. That is true. Yeah, so I guess it was asking, is it determine whether it is true? I feel like I should put yes, but I don't know if I should. I think they communicate the same thing, so. But we'll get both. Okay, but again, notice I did not do order of operations here because the calculator did it for me. Just make sure you're typing it in right. I say that more for my benefit than yours. So next one, -2x, same equation by the way, -2x plus 2y equals 1. But now the x value is a +1, and then the y value, which again is just shown in the ordered pair, is 2.5. my instincts tell me no, but let's just make sure with the calculator. Negative 2 times 1 plus 2, I almost typed that in wrong, times 2.5, positive, enter. And all this stuff right here just gave me a 3. So as I'm checking this, right, which I've just done, I found that 3 equals 1. That's false. So I guess no. No or false, either one. Okay. So this one, now it's given us a table. In the future, they're not going to give us a table. They're just going to give us an equation and say, good luck graphing that sucker. The reason why I say good luck is because the table helps us. They have given us X and Y values to choose from, not to choose from, but to use, and then find the corresponding other X and Y or Y value. If they don't, then you have to choose those yourself, which I think gives people a lot of freedom, but sometimes they don't like it. So on this one, so this first one, it says, see if I can fit it in here. Let's go to the original equation, right? Negative 2x minus 3y equals negative 3. Right here, though, it's asking for the y value when x is negative 3. This one I put in red there, so it's a negative 3 right there. I can't just plug this one in the calculator. We're going to do some work, but I think we'll get through it. So negative 2 times negative 3 is 6. I think some of you guys can do this pretty quick, but I just want to make sure. Now principles of equality, just like we've seen already. Subtract 6 from both sides. Drop your negative 3y, which now equals negative 9. Finally, to make this a 1y, divide both sides by negative 3. And y equals positive 3. Now you could check. I'm not going to because I feel pretty good about it. But that's an ordered pair right there in the table. Right there. You can put it on now. I'm going to put it on later. But you could put it on now, okay? So that's that first ordered pair. Next, we're going to try out y equals 1 and then find its corresponding x values. But going back to the original equation, negative 2x minus 3y equals negative 3, and we'll replace the y with 1. After that, it's solving. So 3 times negative 1 is 3. Well, negative 3 times 1 is negative 3. So now it's negative 2x minus 3 equals negative 3. Let's go and add 3 to both sides. So that zeroes out. I can drop my negative 2x. You'll notice that on the right side it zeroes out, but I need that 0. I need to see some value on the right side of the equal sign, so I need to keep that 0 there. And then finally here, I would divide both sides by negative 2. And that will give me 1x, which equals 0. So that ordered pair is 0, 1. Now, just so we understand, if this is a straight line, so that's all you would need to graph a straight line, but on the assignment as well, they're going to give us more than 2 points to find. So we got to find this third point where the x value is 3. So going back to the original, negative 2x minus 3y equals negative 3, but now the x is 3. So replace it with 3, multiply negative 6 minus 3y equals negative 3. Principle of equality, hopefully I don't run out of space, but add 6 to both sides. Now again, that's to drop the negative 3y all by itself and to zero out the negative 6. Negative 3 plus 6 is 3, and then divide both sides by negative 3, and we see y is negative 1. So now I know the y value is negative 1 if the x value is 3. So they only gave us 3 points to do. I guess if they wanted to be jerks, they could do more, but they might on the assignment. But now we got to put these points on the graph, right, which we've done already. So negative 3, 3, 3 to the left, 3 up from the origin. That is the point, let's see, negative 3, 3. Then we have the ordered pair 0, 1. That's the y-intercept, if you were interested. Probably not. And then 3, negative 1. So 3, negative 1 right here. And you can even see that this creates a pattern, which probably you've seen before. It's like 3 to the right, 2 down, 3 to the right, 2 down. This would continue, but for your sake, I'm not going to do all of them. All right, I'm doing this by hand. On the assignment, I believe you only got to put 2 points on the graph. but I'm doing it by hand. So here we go. See if I can do this okay. Oh, crap.
Close enough.
Here's the thing, though, Scott, is it's math. It's not close enough. So if you suck at drawing lines like I am, like you just saw that I just did right there, I missed both the red and the purple point. We have to redo this. So all I do is make the purple point bigger, and then I make the red one bigger. There we go, okay? All right, this one, it says graph the parabola. On the assignment, what it's going to do is at the bottom of the graph here, it's going to give you options like, I think, straight lines, just points, and then it may show a parabola. I think it's just, let's see if I can do this. It's going to be something like this. It'll show, that's a parabola. Let's pretend like it's a parabola. And then it may show like 2 points on there. All you need is 2 points, okay? So when we graph a parabola, we just need some points to put on there, at least from what I remember anyways. Now, you notice as well, in this one, it did not give us a table to work with. That's okay. We can still do this. All we have to do is choose the values ourselves. Now, this one's set up a little bit different, right? Now it's y equals some stuff with x. It's not x plus y equals some stuff. What this means is that if we start choosing x values, we can find the y value directly. We won't need principles of equality. The calculator will do the heavy lifting for us, okay? So just right off the bat, I like to start with something easy, like 0. And that's not a 0 we would want to ignore. We want to keep that 0 right there, okay? So I've chosen an x value that's 0. Like I said, I'm going to be choosing only x values because it's going to make calculating in this equation very easy. And so I go to the equation, right? I say y equals negative 2x squared plus 3, and I replace the x with 0. Now, you can use a calculator for this. I don't need one because I know anything times 0 is 0. So I get to skip that term right there. But what I find then is that y equals 3. That's why I like to start with 0. So I have the point 0.03. Boom, there's a point. Now we got to choose another point. So I'm going to choose another easy value like 1. But again, it's the x value, right? So I got y equals negative 2x squared plus 3. But I need to replace the x value with 1 because that's the ordered, sorry, that's the x value that I chose. Now I could put this in the calculator. Okay, so negative 2 times 1 to the power of 2 plus 3, boom, I get 1. So the ordered pair 1, 1. Now from what I remember, I think that's all you need on the assignment, but I'm going to continue because I'm having so much fun. So I'm going to choose another point here. Maybe I'll just do it till I run out of colors, but I'm going to choose an x value. I'm going to choose negative 1. Dang it, that's for my x value. Okay, so let's go back to the equation. Y equals 2x squared, negative 2x squared, dang it, plus 3. Okay, but again, I'm going to replace the x with negative 1. Now with the negative here, if you're going to put this into the calculator, make sure you use parentheses around the negative 1. But when I do that, I find that the y value is 1. And that may seem weird. But I now have the ordered pair. Wait a second. I made a mistake. Okay, so I do make a lot of mistakes. I just made a mistake in thinking that I made a mistake. Sorry. Expect me to make lots of mistakes. I don't care that I make mistakes, but some students do, and I still will make some. But this is good. That should be good. Negative 1, 1, boom, that's that point right there. So you can see that a parabola it's just a curved line like this. I want to stop there, but I'll do one more.
It's just going to be flipped, right? It's going to be the other way?
Yes, it is. And now we're going to prove that, though, kind of. I'm going to choose the value 2, because 2, for me at least, would be the next easiest value to work with. Negative 2x squared plus 3, right? And so let's replace the x with 2. Put this in the calculator. Boom. Y equals, negative 5. Okay, so that would be 2, negative 5. 2, negative 5. Boom. Now, the nice thing about parabolas, is if I were to, I'm not going to do it because just for the sake of time really, but if I were to put -2 in there, I would still get -5. Okay, and so I get -2, -5. But you see that this is symmetric. I'm going to put what's called the line of symmetry, which we're going to go over later, but that's the line of symmetry. All right, crap, here we go. So I'm going to try to draw this. Now, I don't think you guys know enough right now to know how bad that sucks, but I'm going to keep it. There we go. Let's try the other side. Crap. That one was bad. Okay, that one's okay because of this. I did it. So you guys are going to be doing this on the computer, so it'll look a lot better. When you do the test, of course, it'll be on paper, but all right, now you may have learned already from square roots like this that the inside of the square root has to be 0 or bigger, okay? And that's going to be important for us because it's going to limit this graph. Okay, so this one is going to have an actual endpoint on this one. But let's look. Okay, so I have to choose my own values here, of course. I would want to start with something that's going to make this inside 0. And if you can do that, that's going to tell you where the endpoint is. So target here, the first target is to make that value 0. Again, on the assignment, we only need two points. I looked it up, so this will be one of them. And we do need it does require you to have the tip. So we make this equation, y equals 4 plus square root of x minus 5. Again, my focus right here is to make this become a 0 value so that it can go away. To do that, I'm going to have to replace the x with 5. So I'm expecting the ordered pair 5 something. Okay, now again, if I do this, well, this is something you could plug into the calculator, but just to emphasize the point, 5 minus 5 is 0. That's what we wanted. Now I've got y equals 4 plus the square root of 0. What times itself is 0? It's just 0. I'm showing more work than you want, but here we go. So now I got y equals 4 plus 0. I'm just going to make that I call it a phantom 0 because it's still there. You just can't see it. And so the y value is, the corresponding y value is 4. So you're going to have to put this on the graph. 5 to the right, 4 up. Boom. That's that point right there. Okay, so you're going to need that point on the graph because that's where we force the square root to be 0. We can't have negatives in square roots because nothing times itself is a negative yet. So we got to have another point, and we want it to be convenient. So let's look back at the equation. Y equals 4 plus the square root of x minus 5. The next value that I want it to be a perfect square so that it comes out pretty. And the next perfect square would be 1. So, and again, I'm speaking specifically about the square root. So how do I make this the square root of 1? I'm going to have to force that x value to be 6. Now you could make an equation and solve that, but again, this is going to be the ordered pair 6 something. Now again, we're doing this with purpose. We are forcing these values to be what we want and not just let it take control of us, okay? So here's what happens. In the square root, I got 6 minus 5, which is 1. In fact, I'll show it in purple. And then I got y equals 4 plus that, square root of 1. What times itself is 1 is 1. So now I got y equals 4 plus 1, which I'm going to show as 5. So I now have the ordered pair 6, 5. Okay. So I'm going to go 6 to the right, 5 up, and it's just barely next to that point. And that's all you would need for that one. And just because we don't have time, I want to do more, but again, you would put those 2 points on the graph, starting with the tip, and then it's going to create a graph like this one. Now, is that exactly what it looks like? No, but I'm doing it by hand, and that's all we need. This is curved right here. It's gonna go flat over here because it's a square root. Because the square roots of things, square roots are going to make them smaller essentially. This is the key point that they want from this, is that you can choose your own ordered pairs and graph them. That's all they want right now. Okay. We'll get into more detail with square roots and parabolas and stuff later, but for now, this is all they really want. Okay, so this one, we got a new equation. This is this takes us back. This is an absolute value, and the absolute value is the distance from x. Distance is always positive, so whatever I put in for x is going to come out of that absolute value as a positive. Okay, well, they've given us some values to use right here, and one of them, well, it should be the tip. You'll see. But we got to go back to the equation, right? So the equation, we got y equals the absolute value of x. Sorry, that's kind of small. That's a little bit bigger. And the first value they give us is x is 2, so I replace the x with 2. Now you can't put absolute values in these calculators, so I'm going to have to show some work. The absolute value of 2 is 2. It's 2 away from 0. And then I got 2 minus 5. Then finally y equals negative 3. 2 minus 5 is negative 3. So we got this ordered pair, negative 2, 3. Then we got the same equation, y equals absolute value of x minus 5. But now the x value is 0. So how far is 0 from 0? It's 0. So we got 0 minus 5, and we get y equals negative 5. I will finish it just because it's going fairly quickly. But y equals, the next one, y equals the absolute value of x minus 5. But this next one, it says that the x value is 7. How far is 7 from 0? It's 7. So I got now 7 minus 5, which is 2. So that is the ordered pair 7, 2. And then the last one that they give us, we got y equals the absolute value of x minus 5, but now x is 9. The absolute value of 9 is 9. 9 minus 5 is 4. So we get the ordered pair 9, 4. So we got this, let's see these points here. We got negative 2, negative 3 right here. We got 0, negative 5 here. And we got 7, 2 here. And then 9, 4, 9, 4 right here. What this is doing, and I'll use some technology so it looks pretty, but it should look something like this. And like I was saying, this is the tip, meaning that's the smallest value we should be able to find on this. Again, there's more purpose or reasons for that, but just for the sake of time, I'm going to have to skip it. So I hit all the points, and I'll put the markers on there, the arrows. Absolute values look like a V like this. If there's a negative in front of that absolute value, it's going to flip it, and then the V would just be inverted this way. So, but it has that same V shape. It's just shifted in some way, shifted or rotated or reflected. And that's a good point. If you need more values to really see what's happening, what I would probably do on this one is I see I got negative 2, 0. I would probably go up to 2 and see what happens. And then you would see that it would, in fact, go through this point right here. And, of course, you could find all these other points. All right, well, that's okay. But, again, once you see that pattern, you'll see that it goes down and then it shifts, and then it's a straight line. So that's the nice thing about these absolute values. It's straight until it shifts, and then it's straight again, just in a different direction. But just like the parabolas, it is a reflection. It's got this line of symmetry right here. It's practically a reflection over that line.